Hi Mechatronics, welcome back. Last time we made this super awesome hand waving device, which I have managed not to break in the last week, which was pretty impressive in and of itself. So today, we'll see how it goes. I'm going to attempt to add a motor to power this straw. So there's a few things I need to do first. I need to make a circuit. So I'm going to start by sharing my screen with you, and we'll kind of move back and forth a little bit. So this is one of the pages in our Canvas course. It's on the Sparkfun kit. So this is the kit that you guys have to work with. If you have different Arduino like devices that you want to use in addition, that's fine. But what I'm going to show you can all be done with this kit because that's what I provided. So one of the things that might be really helpful is the Sparkfun Inventors Kit tutorials. And so there's a link on this page right down there. This page is towards the bottom right now of our modules section. So that link will take you to the Sparkfun Inventors Kit experiment guide. This is basically the online version of the book that you guys have. So you're welcome to look at the book as well. One place that might be really beneficial to get started in wanting to motorize something is going down to Motor Basics. So that's Circuit 5A, Motor Basics. So this is what I'm going to look at. This has the motor driver. That's that little tiny red piece that will click into the breadboard. Motor itself, in this case, they came in yellow housing. A on-off switch, though we could replace that with a different sensor later, and jumper wires. So if we go down, this has a lot of great information about the parts themselves that I encourage you to take a look at if you're not sure how any of them work. You may not have used a motor driver previously, so there's a good description up here about how that piece works, and it is well labeled, as you can see, as to what all of those different pins do. We go down a little bit farther. So this has an explanation of those pins in a little more detail and some advice on getting it hooked up. So here is the circuit to build. So this has your breadboard or Arduino, your breadboard to connect everything, the motor driver, the motor itself, and the switch. If I click on this, you'll be able to see a little bit bigger. So the first thing that I did was I went and made this circuit just the way it looks. Hold mine up here. You can see it in the corner, it's so tiny. There it is. This is a really great place to get started, and that's what I'm going to recommend you start with before you go too far, is just building the circuit as it exists. Go ahead and check, make sure you understand what all those pins do as you go. This one is actually set up to be ready for 2 motors, and right now it only has 1. So if you need a second motor to power a different part of your device, that is ready-made for it already. Okay, so once we have that wired up, we will then need some code for it. There's a hookup table down below that has exactly where the wires should be connected in case the wiring diagram or the schematic aren't working for you. You can also follow along here or in the SIK guide that's in your kit. Okay, but as we know, the circuit is just one piece of it. We also need code to run on the Arduino in order to make it do something. So I'm going to start with copying this code that's been provided and getting it running on the Arduino. So first I'm going to show you the circuit. It's going to be a little hard to see all the details, but you can see there is my motor driver, here is my switch, and here is my motor. So this is wired up just like the wiring diagram we just looked at. Okay? All right. And now we need some code. So I have opened Arduino, and I have pasted in circuit 5A motor basics. I'll zoom in on this a little bit so you can see it better. Okay, so you can see that I have just pasted in circuit 5A motor basics, and we're going to go take a look at how this program works and make sure we know what to expect. So currently pins 11, 12, and 13 are what's controlling motor A. I only have one motor connected right now, so that should be fine. The switch is connected to pin 7. The motor speed by default is 0. And in my setup section, I have pin modes for all of the pins that I've connected. The serial monitor is on because I presume I will be using that. Indeed, look, it says enter motor speed 0 to 255. So it looks like I will be able to control what the motor speed should be. So if the serial monitor is available, so it's going to take whatever I type in the serial monitor and then set that as the motor speed and send that down to the spin motor function down here and set the motor speed based on the numbers I type in. Okay, so I have my circuit and my motor that I'm going to hold so that it doesn't accidentally tangle any wires if it turns on. And I'm going to go ahead and upload this guy. Well, I'm going to check my tools. Got a COM port selected. And I'm going to upload. And then I'm going to remember to turn on the serial monitor. Okay, so it says enter a motor speed, which is good. That's what I wanted to see. One important thing to note here is that I changed this to no line ending. If it always says new line, your motor will not run the way you want it to. So make sure this says no line ending down here. Okay, so let's try turning it on full blast right away. 255. Ah, it is spinning. You cannot see it spinning terribly. Ah, there you go. Spinning motor, hooray. If I flip the little switch down here, it has stopped spinning because that is basically my on-off switch right now. If I turn it back on, back to spinning. And now if I enter a new value, like 100, you can see that it is now spinning slower. Still spinning, just slower. So I think that it is probable that this will still be too fast for my poor little hand waving guy over here. He needs to spin pretty slow. So I'm going to use this to try and figure out what is a good spinning speed for my hand waving guy. So let's try 50. That's a little better. I wonder how low I can go before it stalls out. Let's try 30. That's pretty slow. Maybe 40. I kind of like 40. I'm going to give 40 a try. Okay, so I'm going to start by just turning off with my little off switch there. So my motor has stopped. And now I'm going to go in and make some program changes. Scooch that guy over. All right, so I'm going to comment out this program as it exists right now. Remember, that's a block comment. And then on a new line, I'm just going to have it for now so that when the switch is on, the motor is going. When the switch is off, the motor is off. Good place to start. So let's see. If digital read, I think it was called switch pin, there it is. Switch pin, so we're gonna read from the switch pin. I'm gonna check and see if it's on. And if it is, what do I want to happen? Well, I have this cool function called spin motor that I'm going to use, and I think I decided that I liked 40, so I'm going to go with that. And if the switch is not on, what do I want to happen? Well, we should probably turn off the motor, so spin of 0. Okay, so we're going to try that. So hopefully I've done this all right. When I hit upload, so the serial monitor isn't going to matter for this one, so I'm going to go ahead and close that. Okay, and it just turned on, and my motor is spinning. I'm going to turn the switch, and my motor has stopped. Turn it back on. Motor spinning. Off. Motor stopped. Okay, so far so good. So at this point, could I kind of pause here? Absolutely, that's what I'm going to do. I want to try and connect this to my automaton, hopefully, and see how that works. Could I instead swap out the switch for a more interesting sensor? Yes, definitely. I would hope that you would hope to do that. But for the sake of testing, I now have an on-off switch and a motor. It's a good time to try and hook it up to the hand. So I didn't really plan terribly well for this because this straw currently is how my hand guy moves, right? When I turn this, hand moves. Now there's not a whole lot of power needed to turn this, so that part is good. There's not a lot of resistance in there, but I have to figure out how to attach this kind of flimsy straw with a really wide opening to that motor end. I think tape is going to be my friend. I also think this is really long and silly, so I'm going to shorten it and try and do it more, you know, like that, so that maybe then I'll be able to even attach the motor somehow. Okay, so I have scissors and tape. We're gonna see how this goes. Hopefully it won't ruin my perfectly nice hand, or I'll have to remake the whole thing. I'm going to trim it. It feels very final. I'm suddenly very nervous. Okay, so I have trimmed the straw, and now, so this guy has kind of flat sides to what the part that spins the motor. Can you see that? So I'm going to, I think, try and like get some tabby parts on my straw and tape to those flat parts in the hope that it'll be easier to hold on to than the kind of round parts. I probably would have done myself more favors had I thought a little more critically before I started about exactly how I was going to attach this to a motor, but off-the-cuff projects often don't get the level of planning that we might hope, and hindsight is 20/20. This is what happens when I do things live without like planning them ahead of time, but that's okay. Good engineers are good problem solvers, right? We're going to solve this problem. Okay, so I have cut my straw so that it has kind of these tabs on the end. Yeah. And I'm going to try and tape those to the flat part of the motor as soon as I find my tape. Okay. Tape. I'm going to need thin strips of tape. I'm going to tear those. Maybe again. Using my big fancy computer as a tape holder. It's great. Okay, so tabby things. Motor. I think I'm going to like it better with the wires sticking away, so I'm going to try and tape it like that. I need more hands. Oh gosh, my straw is longer than I thought. It's gonna be way out there. How do I feel about that? Well, you know what? If it doesn't work, I'll get another try because I'll be able to cut it shorter and go again. Okay, so I'm gonna be okay with this. I'm gonna try and hold all of these things at the same time. Go, tape, go. Maybe I should have gotten stronger tape. Little tape flag in my way. Perhaps this will inspire me to become a better video editor so that I can shorten all this for you guys. We'll see. Or maybe it will be comforting to you to watch me struggle. That could be true too. All right, I might have gotten one side taped in place. Maybe, we'll see. Now I'm gonna kind of squish the other tab in place and get some more tape. And I'm gonna attempt to wrap this really tight. Maybe I'll try for one more over the top of everything since I've got it ready. Okay. It's kind of taped on there. Well, nothing for it but to plug it in and see what happens. So I unplugged it from my Arduino board so that I could kind of wrestle with it. I'm gonna plug it back in. Now would be a good time to remember whether it was running or not running when I unplugged it. So try to note that for yourselves. Oh, okay, good. It was not running. Okay, so I'm gonna try and balance all of these things where you can see them. Here's my hand, my straw, here's the motor. If it works, well, we'll be very happy and surprised. Oh, it's kind of working. Let's see. Yeah! Oh, I'm excited. Look, it's okay. It's very fussy, but it is working. So when I keep it lined up correctly in the front, it spins okay. You can kind of see from the side that it's nice and vertical. But if I pull it out like this, it kind of stalls out because there's too much tension. And if I push it in like this, it kind of tries to break itself. Okay, but if I can keep it the right distance, it is indeed waving at you. Oh, I'm so excited. Hello, everybody. Okay, so this is slow good news. It's slower than I expected, actually. So I'm gonna see if I can carefully turn it off. Ah, there we go. And I'm gonna go back and the only change I'm making to my program right now is I am turning the spin motor from 40 to 60. Okay, and it says it's ready. We're gonna try that again. Okay, again, when I keep it all lined up perfectly, it's kind of working. I like that hand waving speed better. Okay, so motor speed 60. for my hand waving robot. Okay, so right now I have this guy running with just an on-off switch, which is okay, but perhaps next time I will add a sensor and make it more impressive. And I gotta find a way to like hold this motor still, because this is not gonna work for me long term if I have to balance like this all the time. Turn off. Okay, I'm gonna put the hand down. Whew. I'm actually really excited that that worked as well as I did. I was pretty sure that I was gonna rip the whole thing apart and have to start over. Okay, let's screen share again here real quick. Okay, so if we go back to the program that I was looking at, so this is currently still the Sparkfun Inventors Kit Motor Basics that I just made 1 or 2 changes to. So if this was a program that I was going to try and use for mine, I would do things like get rid of all the code that's not mine, right? That I'm not even using. All that big giant block that I commented out, we got rid of that. Up here, we would change this to now say, this is the header section, right? You should always have an accurate and an accurate and helpful header. So my name, the date, program to run my amazing hand waver, but based on Sparkfun Inventors Kit Circuit 5A Motor Basics. I'm using their spin motor function, and I'm using their setup section, so they absolutely need to be given credit for what I have used of their sample program. I'm even gonna leave all of the who it was written by, as well as downloads and instructions to their original tutorial, because that is the setup that I followed to start with, right? All of these things are really important. You should never use someone else's code, even if it's published like this, without granting credit where it is due. Good. Anything that I changed now, I need to go ahead and comment what I changed. So down here in the loop section, now what does this do? Turn on if switch is on. Turn off if switch is off. Okay, so it needs to be in there explaining what you did. That's how I know that you wrote it and you understand what you wrote. I also like to go ahead and auto format so all those things line up nicely. The spin motor function we're using exactly as is. You don't need to go in and change the comments that because they still apply. We're using it just the same way. Okay, so this would be acceptable, right? My name and the date, what it does, make sure that I am giving credit for all of other people's hard work, and not taking it as my own, but adding comments for the things that I did write myself and change. Okay, so I'm going to stop there. We now have a motorized hand-waving recycling bin robot. Very exciting. Hopefully next time I will make the motor mount a little more stable, and maybe add a more interesting sensor, because the switch is kind of boring. I bet we could do better. Okay. All right, that's it. Have a great day, guys.